Problem solving is a key skill every supply employee must have, and we have been cultivating improved capabilities in all levels of our organization through VPO for many years now. However, we see a lot of inconsistency with the quality of problem solving efforts across the globe. Today, we're joined by our Chief Supply Officer, Pete Kramer, to hear his insights and observations on the topic of problem solving based on his travels to our facilities in all zones. Hi, Pete.
Hi, Peter.
Thanks for joining us today.
Of course.
So we wanted to get your opinion on the 100% mindset that you've been talking to us about and share what that means for everybody across the globe.
Well, 100% mindset is very simple. The concept is that all of our machinery, and it doesn't matter if it's a packaging line, a brew house, utilities operations, malt house equipment, glass plant, rice mill, whatever, the equipment should never stop. It should run 100% of the time. And we somehow have built this notion into our routine that somehow we think it's okay for it to run only 80% of the time. Because at some point, when the equipment was new, it probably ran better. And then during the history, it started to run less, and we kind of just kept that lesser number in there as our standard. So we're trying to get back to 100. So all of our equipment should run 100% of the time, and it's really not okay for equipment to break down.
Okay, so that explains why we have uptime on our packaging lines at the workstations and the top machine issue that we're tracking as PIs. So how does that relate to a brewing process, a malt house, or even a soft drink facility?
Well, uptime is a critical PI. And I think it's a little bit simpler to follow maybe on a packaging line, because if you're running a piece of equipment, let's say you're running a packer, the notion is simple, right? That packer should run 100% of the time, and your PI should track every minute that it's down. And when it's down, we should be reacting, not just to start it back up, but to figure out why it shut down in the first place. If you take that same notion to a brew house, for instance, usually our brew houses, most of them are automated, but this can apply to a manual brew house as well. But if you're running an automated brew house, you have a control system that is running the process, right? There's a PLC program, you have instruments out there, and the system should run in automatic. But what we often find is that equipment does not always run in automatic. We put it in manual. Or for some reason the equipment shuts down and we restart it. And what we have to do is we have to have the 100% mindset again. We've got to remember that the control system should run it 100% of the time. So if the equipment is in manual, we need to put it back in automatic, and we need to figure out why did we need to put it in manual in the first place. Because the control system should run it 100% of the time.
Great, thanks Pete, that makes a lot of sense. Switching gears a little bit, can you talk to us about the quality of 5 whys that you're seeing across the globe and what we need to do differently in our approach?
I see a lot of opportunity. I'm kind of laughing because it's something I see when I travel. We have a huge opportunity for the quality of 5 whys. I travel to all our breweries, all over the globe, and our verticalized operations and our distribution centers, and we're asking people to solve problems. And when you're running a line, you have an issue, you get your line going again, and then you start on your 5 whys. Well, let's use an example on a packer. So you're on a packaging line, and the packer stops, and the cartons that are being fed into the packer are what caused it. So you straighten the cartons back out, you press start and run, and then the cartons feed and the equipment runs again. Once it starts running again, then you have to figure out, well, what happened? Why did that equipment stop in the first place? So you look at the carton feed, and you notice all of a sudden, after 10 or 15 minutes, all of a sudden the cartons start shifting a little bit, and they start shifting more and more, and eventually they shift so much that they're blocked by the sidebar and they don't feed anymore, and the equipment stops again. So now you've made an important observation, right? So you start your 5 whys and you figure out, okay, why did the equipment stop? Well, because the cartons were shifted. Why did the cartons shift? Well, the cartons shifted because they're vibrating, and there's not enough cage around them or supports around them to hold them straight. And you figure out why is there not enough support around them? Well, because the original design of the carton feed was for a different carton, and the carton has changed over time. And you can keep going on. Well, why did that happen? Well, the design engineer didn't spend enough time on it and didn't get to it. And eventually you get to the root cause that we have an equipment design problem here and we need to fix it, right? So what do? You figure out how to, maybe you put some drawings together on what you think can be done. Maybe the problem's too big for you, so maybe you need to call a process engineer who's an expert in carton feeders. Or maybe you call your subject matter expert who knows where else we have the same equipment, and maybe we can just copy their carton feed if they fixed it over time. But those are the things that you need to do to figure out why did the problem happen in the first place, fix it permanently, so redesign the carton feed, and then that problem will not happen, and your line will run better, and you'll have much less downtime or much better uptime.
Okay, great. So as you were talking there about the operator initiating the 5Y, involving the technician, maybe even the subject matter expert, that's the perfect example of using the 5Y relay race. To get those people involved, how would you escalate the 5Y from the workstation to get those people involved? What would the avenue be to do that?
Well, if you look at how we've designed our workspace now, we have the operator workstation where the operator has everything they need to run their line, theoretically, right? So they've got their tools there, you're tracking PIs, whatever it is that you need to run your piece of equipment in your area. But if you take the relay race example with the Packer feed, for instance, if we go back to that, redesigning a Packer in feed may be a little bit too much to get done on an operator workstation. And you may need help with that. You may need engineering help. So we've also designed the team room for all the people that work on the line to come together as a team, because we're running this line together as a team, to get help. And within that team, you may have more resources, right? You've got access to process engineers or plant engineers. We've got access to electricians, machinists, others that can help with the process. And so the team room, the whole objective is you bring the problems that you feel like you've gone as far as you can, and then you ask for help, and you kind of, the next person can take it from there and help develop it. And maybe the engineer will look at it and say, you know what, we have the same packer in another brewery on the other side of the country. That person gets the design, brings it back. Then you guys all get together again. Maybe the machinist looks at it and says, oh, I can redesign these rails, no problem. I'll have it done in a week. And then they hand it back to you once the equipment is redesigned, and you start it and you see how it runs again. And that would be a perfect example of a relay race, how you took the initial problem solving as far as you could, then the next person helped and they did their piece, and the next person helped and did their piece, and then they brought it back to you again to see how it all worked.
Perfect. Along the way, I also envision that the operator will be working with a technician, and there'll be some knowledge transfer there, so that over time, the operator will pick up more and more knowledge from technicians, subject matter experts, and ultimately upskilling over time, correct?
I agree. You know, if I look back at my own career, the time that I really learned the most was when I was solving problems. If everything's running great and you're just kind of monitoring, there's really not a lot of learning going on. But when you're doing a 5Y and you're studying how does a piece of equipment work, how is it designed, what possibly could be wrong with it, all of a sudden you have to learn a lot about how switches work, how equipment guides work, how do PLC programs work, why are they written the way they are, and there's this major learning process that goes on, and then once you've learned all these things, we have to make sure that we retain that knowledge and we pass it on, right? And that's so with if you look at the team room and the way it's designed, after you complete your 5Ys, the next thing you absolutely should be doing is figuring out, okay, how do I, we have all these materials, like we have process maps, we have standard operating procedures, we have checklists, we have maintenance procedures, we have preventive maintenance procedures, we have overhaul procedures, all kinds of things. And they're all mapped